Hello, my name is Krzysztof Romanowski, but call me Roman. I work as a lead platform engineer at Roche. I have around 8 years of experience working with Kubernetes in various environments and over 3 years of experience in deploying, maintaining, developing and upgrading Kubeflow. I want to present the current state of the Kubeflow Helm Chart that I've been working on for a couple of months now, describe some of its advantages, the idea behind creating it in this form, tell a little about the work that is currently in progress, and show a demo on how to use it and start playing around with it. This work comes from my personal experience around Kubeflow in an enterprise environment. There are environments where it is required to have a specific configuration for various components because of the company policies. This can be related to the configuration of Istio, Cert Manager, or other components. Also, sometimes teams simply need some good conventions around maintenance and parameterization when configuration options should be controlled and oftenly parameterized or chained directly from the output of infrastructure as code tools, and not just left with the defaults. From my experience, this is extremely useful approach if you are a one-man army and cannot remember every single detail of your setup, and instead just want things to kind of click on their own or throw an error if some breaking changes were introduced. One of the good practices I learned from administration and development of various infrastructures is that the mechanism of opt-in is much easier to handle and understand than opt-out. To put that into perspective in Kubeflow environment, if you have a need of specific Istio configuration, you will either provide a lot of customization patches or disable the component installation and provide an Istio deployment of your own. This raises separate issues requiring some conventions to handle and remember. With the patches approach, one has to care for the names and configurations, for example, for config maps, secrets, and variables, and so on. If the configuration comes from IAC, with customize, this has to be propagated either by human input, which introduces error-prone setup due to human error simply because a naming convention might change or because of a typo, or some third-party tool like envsubst or a Helm chart that parameterizes the customize, but this is just a workaround with the challenges of its own. In the case where you define a component by your own and not just configuration through patches, you have to understand and oftenly reverse engineer the manifests or even code to understand what's where. One of such examples that requires deep-level reverse engineering is the definition of istio-ingressgateway principal or a service account identifier, which, although parameterizable, was just hard to guess and find how to do so. I will show where and how this principle is defined in the code and in the Helm chart later. So all of that, this suggested an approach where the Helm chart should only focus on the Kubeflow component itself and enable easy parameterization between the components and provide integration manifests for the dependencies like Istio, Cert Manager, DEX, and so on. With this, the idea is that a minimal set of changes in the dependencies are required, and sometimes using the defaults would be just enough. Having all that in mind and putting to an additional perspective where in my company we want to define a common way of Kubeflow deployment supported and accepted by the company policies and easily usable across different teams and projects within a single company, the idea of investment in Kubeflow Helm Chart was born. Initially, that was my personal project for a proof of concept, but when I showed it later to the team in my company, dedicated to sharing expertise and improving the ways of working with Kubeflow, and later with the Kubeflow community itself, it evolved into a project that proved that it's able to deliver. Now, let's show some stuff. So I want to start with this GitHub issue. So this is just poking around, is the idea of Helm Chart going to be implemented at some point, or if there are any plans. So here is my comment about this work that I'm going to present to you, some information, some assumptions, and a quick start installation. So I want to go through the quick start installations. Let's go for the Helm first. Yeah, this is using plain Helm and nothing else. Well, maybe the kubectl will apply here. We will just create the Kubeflow namespace with the proper Istio injection. This script will also first tell you what is going to happen and give you a time to cancel the script if you are not interested anymore after reading this information. So it will execute Helm upgrade installs for the dependencies, mysql, minio, Cert Manager. Istio, because it's installed with Helm, Istio Helm installation goes through these three separate Helm charts. In customize, in Kubeflow manifest customize, there are a few directories that will kind of combined with the output. So this is presented with everything else as one set of manifests. Moving further, here we have the metacontroller. Here we have Argo workflows, Kubeflow Helm Chart that is a part of this demo. And here we should have a URL like similar to this one. I forgot about this specific thing, but it is still usable if you first clone this repository and get into this example Helm Chart directory. But moving further, there is another example for Argo CD, which is basically doing the same, but it will first verify if Argo CD is installed or deployed, and it will deploy if it's not available. And then it will apply some of the applications. And as you see, it's already a little faster because here we are waiting for every of these components or dependencies to be ready. Here we can, this is kind of like a sync waves, but controlled from this shell scripts. So we apply a bunch of Argo CD application manifests and wait for the pods. Another bunch, this includes Kubeflow and istio-ingressgateway. It's as a side note, it's important to know that istio-ingressgateway, when installed by Helm Chart, it should be installed after the istiod pod is ready. There is some additional configuration made through mutating webhook configuration. So that's why this pod wouldn't be ready until istiod is successfully deployed. So moving further, this deploys Kubeflow, and then we wait for all of the Kubeflow components to be ready. We apply the Argo CD that just holds one single manifest for the profile. So this is actually what should be used in here. So you can also just modify the script or use this one. Or even best, you can use this third quick start for app of apps. It was proved to be the fastest current way of deploying Kubeflow, at least with this Helm chart that I want to present. So this script will first install Argo CD or deploy. It will configure it for the app of apps sync waves. Here is also a little information on why that's needed. Wait for Argo CD and then just deploy the app of apps manifest. So this is the app of apps manifest. It basically references that every file that is compliant with this glob pattern should be included, and this specific file should be excluded. So next, I want to show that there is a GitHub page based on this repository that also presents information in a very similar way to the GitHub issue about how this Helm chart can be installed, what are the quick start installation options. I was also able to verify that at least some of the functionalities are already compliant with the EKS setup, which is mostly about setting the OIDC issuer for machine-to-machine tokens and some annotations for IRSA. So, moving forward, what do we have in here? This is the repository itself. As you see, this is forked from the Kubeflow manifest, so most of this stuff you should be already familiar with. And this Helm chart is here in the chart/Kubeflow directory. Please don't mind this profile Helm chart. This was just for some experimentation, and at least at this moment, it is not planned to maintain, but we'll see. And Kubeflow Helm chart by itself. So as you see, there are no dependencies. Everything is handled within this single Helm chart. But the structure here is really important. I wanted to provide the structure in a similar way as if I were to work in a monorepo. So because of that, the nicely defined directory structure is important to understand what's happening and where. And this is true for the components and also for the component functions. More on that later, but right now I want to show you the values file. Let's first show if it's big. Well, it's big. 1,300 lines, but a lot of those are good enough to live with the defaults. So let's focus on what's at the beginning. Okay, let's go with the defaults. The defaults section is pretty nice because you can modify the registry, you can configure some default autoscaling configurations, you can define some scheduling options and container security context, and this should be set for every single deployment or stateful set or whatever is there for Kubeflow components. So other things like Istio or to proxy DEX, you will have to configure them on your own. And moving further, so here we have a section specific to central dashboard. We can override the registry, change the repository, change the tag, define resources for the deployment, define some specific stuff for the service for the central dashboard, some autoscaling. So as mentioned here, if is disabled, the replica count for a component is equal to min replicas. But if this is empty, then this is taken. So I think it provides pretty nice interface. Pod disruption padded, config, airbag, service account for which you can just specify your own annotations or even reference a already existing service account. Some about the scheduling, and then the config. This config is long because the options of configurations for central dashboard are also pretty long. So you have the menu links, you have external links. If you know central dashboard at least a little bit, you should understand what this references exactly. So the quick links, the documentation items, after all, they will just show as links in widgets in your central dashboard view. And then the notebooks, and as you can already see, the image section is already with the same structure. I didn't mention we have this enable toggle for every of the components. And then again, service, autoscaling, airbag, service account, and the logos. These are the logos for the notebooks. So currently there are Jupyter, Code Server, and RStudio. So you can define your icons for those on your own. you can also define or actually reference a config map if you have a config map with those icons by yourself, or you can use the default, and the defaults are just in a file or a template actually. So this should be for the Jupyter web app config map logos, and this is just embedded. This is SVG of the icons. So what's next? The spawner form defaults. So if you, for example, have the images or some other images that you support or want to allow deploying on your infrastructure, you can also just point a specific config here. If you are familiar with the Jupyter Web App spawner config, you should already have a grasp on what's happening in here. Then the notebook controller, it's kind of the same. Well, it is the same. The structure is the same. Some of the values, like the repository, would be different, but then everything else should be in the same format. And here's some configuration specific for the controller. And it goes on and on. The pipelines, though, it's a little bit different because the container registry for other components is served, well, here in the Docker.io Kubeflow Notebook notebooks working group. For the pipelines, it's a little bit different because the pipelines itself are supported and used by GCP for their own machine learning platform. So that's why they host it exactly in here. But as you can see, the structure of this is again the same. The only difference for the image specification is that the first one was in the defaults, and now we have this specific in the pipelines. And then when it comes to subcomponents like the cache, we again have the same structure for image, resources, service, airbag service account, and the config. One thing that is currently configured for the development, but already is planned to improve, is the configuration or credentials for the database or object store. Currently, this is just set in plain text, but there will exist a possibility to define it both as a plain text value and a secret reference. So this again goes on and on. You have sections specific for configuration options or the deployment options. There is another thing I want to show, and this is related to the integration options. So for example, the Cert Manager integration, this can be easily enabled or disabled. Istio integration, again, the same. And those integration means that this Helm chart will not deploy those components, but there are various manifests in Kubeflow world that needs to be there to integrate with those components. So for Cert Manager, this will be the issuer or certificates. For Istio, those will be the virtual services or gateways or destination rules. And there is this additional config for some of the dependencies, like Istio. There is a way in Istio to provide a configuration in a config map that will point to external authorization provider. And you can do this through envoy filter or through the config map or mesh config actually provider. The latter is more supported and suggested by Istio. So this is also why it was configured in this way. And also, this is already a part of the Kubeflow manifests. It was merged some time ago, and I was working on this specific integration myself. So this should also be working and integrating pretty nicely. Then we have some components or configuration for components of Istio. And so the root namespace can be changed. The istio-ingressgateway namespace can be changed. In Kubeflow manifests, the namespace for the istiod and ingress gateways is the same. It's Istio system. And while this is fine, official Istio docs always reference within the quickstart that they install Istio Ingress in its own namespace. So I wanted to provide this as a possibility. Now, also depending on how you install Istio Ingress Gateway, what name will you give it? And if you install it through the operator or through the Helm chart, there will be some differences, and specifically for the service account name. This is important for some of the integration manifests around Istio. And actually, later I will show you a specific example of why this specific parameterization option was needed, and that sometimes a deep understanding and reverse engineering of the Kubeflow itself is a good thing to have. We have also a section for machine-to-machine authorization. By default, it's enabled, and by default, it uses the configuration for self-signed OIDC issuer served in cluster. This happens, or this is configured when you are using minimalistic Kubernetes environments. So Kind, vCluster, Minikube, all of those will have the OID issuer configured as in cluster and behind self-signed certificates. So the self-signed certificates here are a bit of an issue because OAuth2 proxy then has to be configured to trust or actually ignore the SSL, the incorrect SSL for self-signed certificates. And Istio also has to be configured, well, basically with the same. So it has to trust the self-signed certificates. Well, for Istio, it's a little bit different because for OAuth2 proxy, we can just say ignore. But for Istio, we can do one of two things. Either take the issuer Jwks and embed that into request authentication, or configure Istio with additional certificates authority. And the first thing is much easier because then we can just have a job that verifies, takes the JVKS, it performs sort of the auto JVKS discovery and embeds that into the request authentication. And it is done through a CronJob that runs every minute. It's useful because if you, well, the JVKS is a matter to change. So if it changes, you want it to be quickly propagated. So that's why it runs every minute. And then the JVKS are used both from the DEX integration and from the service account tokens integration. Both uses the Jwks under the hood, and the user details are presented in different claims. So for DEX, we obviously want to use the emails. And for the machine-to-machine tokens, so service account tokens, you want to use this subclaim, which provides information on the service account identity, or a principal, actually. We can also define a different gateway, choose a selector, and define the configuration of the gateway servers. Then there is also a DEX integration. This will technically just provide the virtual service. Ingress is not yet supported. This is something that I think might be relevant at some point because I'm also investigating if it's possible to deploy Kubeflow without Istio and rely just on, let's say, AWS Ingress load balancer or application load balancer. But let's see. Currently, this is not supported, and Istio is a requirement. That's why we also have this integration type and integration mode, but let's not focus on that. It's not yet fully supported. And then the authorization config. So user header name is Kubeflow user ID. This is the default, but if you have some other setup and maybe, for example, you don't want to depend on OAuth proxy or whatever, you just want to use different header, you just set it here once and it's propagated to every component that requires that. Cluster domain, I hear it's important for OpenShift installation, so there's that. Right, so this is the summary of the values here. Next, I wanted to touch on some of the specific files or templates to show some of the conventions. So as you see, most of the stuff is used through the Helm functions. Why this was important? So first, it provides some unification. It also provides some naming scopes for convention. And sometimes, as you noticed, the common structure of some configuration options is used. So for the autoscaling, you have probably noticed we have, every time we have this structure. So here and here and here. So having that, we can define functions that reference those configs and just present them in a nice way. So let's check this Kubeflow Central Dashboard autoscaling min replicas for now. The function definition, and under the hood, it includes the more generalized function that then accepts some arguments and can make and can bring the correct value based on the defaults and on component-specific config. Let's go to where this specific thing is defined, so you can see the logic. Right, so default autoscaling, component autoscaling, we verify if component autoscaling is defined, we use the default. Right, so here is the logic. It is also very similar for the labels. We also include Kubeflow common labels and then Kubeflow component labels for this specific name. The name of the component is also parameterized. This might sound a little bit like an overkill, but I think there is a good argument for that, because every single name, like the service account name, the role names and role bindings, the config names, those will use this specific name. And then this includes the Kubeflow component name, which by itself is yet another generalized function. So if we want to change some naming conventions for every single name for every single manifest, we can do it just here. Or then if you want to change the naming convention just for this specific component, you go to this specific component and change it just here, and it propagates pretty nicely. So that's the general idea. You also have similar section for images. So we include the component image function, and we provide either the defaults, so image from the defaults, and the central dashboard image. Let's also reference that. So it gets the registry, the repository, the tag, and then just prints this value like that. So I think it provides pretty nice interfaces, because this is defined just once. This will be then used in every other single component. So if you want to change the logic somehow or the structure, you also already have some conventions for that. And one could also use just that, so ignore this abstraction layer. But then having the image defined just like that, and having this as a common convention for every other configuration option brings some clarity and conventions. And also then you don't have to remember what is the specific ordering of the arguments. And the templated manifest, it looks pretty nice. At least it's easier to understand than having all those embedded functions. Right. Yet another thing I want to show you are the aggregation labels. So this is something important for the Kubeflow roles. And as you probably know, there are aggregation rules for different roles. So that depends on what components are you deploying exactly. And you have also those admin roles that also uses the aggregation rule. So to ease the work around that, there are also helpers for the aggregation labels. Yet another abstraction just provides the role name. So let's show an example of how it's defined in its own specific helper. Let's take this one, for example. Here we have the helpers. So Kubeflow roles. And again, we just include the label base and the Kubeflow pipelines edit role name, which by itself uses the Kubeflow full name because it is supposed to cover for the cluster installations, and the pipelines edit for specific role name. And then this is referenced in other places in this and different templated manifests. So it should be pretty easy to use and extend. Another thing I want to show you is specific to this istio-ingressgateway principle. It is defined like that. And so if we were to see what is the default, so this would be the default. The name is istio-ingressgateway service account. And now, if we want to rely only on Helm charts, this becomes a little complicated because this is the service account name that will be provided if Istio is installed with Istio operator or istio-ctl. But if you install with Helm chart directly, the service account name is just the istio-ingressgateway. That's why it was parameterized within the values, so you also have control on how you install Istio specifically. And this is one of the examples of why it is important to have a good parameterization, because this was found in Kubeflow/Kubeflow repository, but in Kubeflow/manifests, this is not propagated. So if you don't know that it is possible, or you don't poke around, the Istio integration just becomes a little bit more cumbersome, and you have to reverse engineer. And I was also looking into why there is a difference in between the Istio installation methods. So in in Kubeflow manifests, here we have some instructions, and this is basically using the istio-ctl. And istio-ctl uses pod operator under the hood, and there is actually this note that istio operator is, the usage of it is discouraged. Here I'm a little bit confused because it says the istio operator usage is not suggested or discouraged by, but then when we go to istio-ctl, it also uses the istio operator, at least for the manifests. Well, whatever. The Helm, we are focusing on Helm, so let's stay with that. And just as a little example, here I have the Istio installation with istio-ctl, that is using the pod operator under the hood. And I also want to show you this README from Kubeflow manifest about maintaining the Istio manifests. So basically it uses the istio-ctl for specific version. It uses the, it dumps the manifest. It uses some profile overlay that can be also defined or seen here. So here I executed those steps, and I did that for istio-ctl for 1.17 and 1.1. So here in the dump, we can find the service account, for example, for the cluster local gateway, but istio-ingressgateway is the one that I wanted to show. As you can see, it uses the suffix for service account. Now, if we were to use Helm template for istio ingress gateway from istio, right, I want to use that's because I have it on different machine. Let's move here then. Helm template istio ingress gateway, istio gateway. Oh, and the first object is the service account. And as you see, the name is just istio-ingressgateway. There is no suffix. So that's why it was important to parameterize. Now let's jump back. Now I want to show the quick starts and the installation demo. So I want to first focus on my machine. This is running on the WSL, Windows Subsystem for Linux. Here we have the commands executed. So we just created the Kind cluster using the Kubeflow manifest definition of Kind cluster for GitHub Actions used for the tests workloads codes, and then we executed these apps of apps. It actually should be app of apps, so this is a typo, but I think it's fine for the moment. This is still work in progress. So it mentions what was said previously. There is an information that it will install Argo CD, configure it to enable health assessment required for sync waves, and apply or deploy the app of apps manifests. Also, if you want to apply the app of apps manifests by itself, just cancel this script and execute this command. And as previously seen in the script, the only difference is that this script will first install and deploy this manifest. And if you have Argo CD already configured for the sync waves, you can just apply this and it should be working in the same manner. So the Argo CD was applied, the patch was executed, we waited for Argo CD, and then we applied the app of apps. So I executed that a few minutes ago, so let's see if it's usable already. The thing about using setup with WSL is that there is some overhead for the processes execution, for the networking. There is some validation done by Windows under the hood, so it will be a little bit slower depending on your machine, but it's at the same time the easiest to show the central dashboard and the UI by itself. So let's get Argo CD apps. As you see, it's progressing. The dependencies are already installed. You cannot see it at the moment because I executed that some time ago, but the sync waves were properly executing or deploying specific manifests when previous manifests were in the healthy state. So let's see what is happening right now. Okay, going from the top, the Cert Manager, Dex, istio-ingressgateway. As you can see, istio-ingressgateway was deployed a few minutes after istiod, which, as I mentioned before, it's important for the ordering and for mutating webhook configuration. This specific cron job ensures that the JVKS or JWKS is embedded into the request authentication for machine-to-machine tokens in self-signed OIDC issuer environments, so Kint or vCluster or Minikube. What else? The Argo workflows, workflow controller, central dashboard, minio, mysql. Some of the pods are initializing right now because the container images are downloading, and or Windows runs some checks under the hood for the process's execution, some security stuff. It will still take a few moments to finish. So in the meantime, I can show you another environment that is faster. And it's faster because it's not on WSL. It's on EC2 machine. So we have some cluster initialized, but let's do it from scratch. And now the only other requirement is supposed to be running this script. So Argo cd app of apps. All right, the cluster is ready, so let's apply the script. Now, because this is Kubernetes in Docker and the cluster was freshly installed, there is no caching of the images. So we have to wait for the downloads. It should be pretty fast considering that this is a EC2 instance. For reference, we can also later delete the app of apps manifest, see how the cluster is deleted or destroyed. Well, not cluster actually, just the Kubeflow and the dependencies. And redeploy again, having the container images cached on the Kint nodes, and then it should be faster as well. As you see, Istio is already propagating, so let's actually see the applications. I will fast forward so you don't have to wait so long for the installation. I want to show what is happening here on the Argo workflows controller, just so you are not surprised. There is a little side effect that will become eventually consistent. All right, I have to. Yep. So it says it fails to register to watch for controller. Let's see what this IP is responsible for. Okay, so this is the Kubernetes service. This is related to Istio. Right. So Argo Workflow Controller started its process before Istio sidecar container was able to modify and handle the traffic. Just to verify that it is the sidecar, let's see if the sidecar is there. Yep, the controller and Istio proxy. So after some time, it should just restart. So let's give it this time. Also, other pods are just initializing. I noticed, oh, and it just restarted right now and it's working again. So this is nice. I also want to show you what is the effect of this job. So this specific line is added by this job in order for Istio, so it doesn't have to call this issuer for well-known OIDC configuration, because calling this URL will just result in error thrown because of these self-signed certificates. So if we were to do this specific thing, Istio doesn't have to call the issuer anymore. It just verifies the JWT against these keys, Jwks keys. All right, so it happened that it should be working already. So the Kubeflow user example namespace is running correctly. How long did it take to run? Assuming that we are counting from the Argo CD installation, it took like 5.5 minutes. All right, so what can we do with this setup? What can we verify? So first, let's see the M2M tokens. Oh, and I have to execute the port forwarding. So there is that. And now I can call some curl to this port forwarded service. And there are two specific things that you might notice. First, we are using the pipeline API in version v1 beta 1, and we are trying to list the experiments, and we are saying that we are filtering through the namespace, and the namespace name is this one. We are also saying that we want to add the header. The header key is authorization, and the header value is bearer and the token. So if we execute just this part, we can see that there is a JWT. This is a kind cluster So what I'm going to do is to show you some details that we can get from using this JOT. It defines the issuer as expected, the sub. So this is the principal of our service account. Under the hood, Kubeflow uses subject access review and review tokens, and those can understand this format of principals. So it's nicely integrated with Kubeflow and Istio already. So we have that. Now we would like to execute that, but let's first see what will happen if we don't add this header. It just asks or redirects to the login URL, which is for this. But let's try and execute this with this token. Okay, it presents an output of empty list of experiments, which is fine. We just installed the Kubeflow cluster. If we were to create a new experiment, this would be the command. It's very similar. The difference is that it's using post. We are also using the authorization header, but we are also defining some data. And this is a JSON that represents the required data to create an experiment. The name and the resource reference, because it is required for experiments to be defined for specific namespace. Can we forward that to the queue? Yep, it is created. And now if we were to get the experiments, previously the output was empty. Now the output, sorry, now the output is the are the experiments. Okay, so let's try going back to WSL. It seems that everything should be up and running. So right now we should be able to go to localhost and log into Kubeflow. Oh, we are missing one thing. I need to configure port forwarding, of course. Let's try again. Now it's working. Email and password are the common defaults, so user@example.com, and the password is 12341234. Nice. This is Kubeflow. So not everything of those components is currently deployed, but there are some things that are deployed. So the notebooks controller, as you have seen, we should be already able to test that. So let's deploy some test notebook and launch. We should also be able to see that in the output here. So Kubeflow user example.com, the pod is initializing. This is our notebook. Nice. What else? Volumes web app, it's not there. Tensor boards, it's not there. Endpoints, AutoML experiments, KFP experiments are here. The experiment that we created was created in a different setup on the EC2 instance. So we can create an experiment through the UI. And as you see, it's here. Or we can execute the command that you have seen in this environment. Let's copy the command from here. Yep, it's created. Name M2M experiment, and we should be able to see it in here. Correct. Let's also see the xget, and we also see those both experiments. So this proves that the authorization works both when used from DEX and through the machine-to-machine tokens. What else? Maybe let's try to run an experiment. Let's run one with the first experiment and second with the other experiment. So right, it says that both are running. Let's see. They are initializing in here. We can also see the workflows. So it will take like a minute or two for them to complete. And in the meantime, we can also create a recurring run just for fun. And let's run it every minute. It should show in a few moments the executions, the artifacts, the logs from the steps, this is expected. You already have an output here. We can download, but can we open that directly? Well, it just defaults to download. Anyway. Oh, and the recurring run also has started. And it just also works as expected. Well, this step output is taken from cache. So there is that. The notebook, it should be running already. Can we connect? I was able to verify that the issue was caused by reaching the limits of memory on my computer. This is running on WSL, and this is the same machine that is running the recording. So because of that, I'm recreating the cluster just to show you that the notebooks will work in fact. We will need some minutes for that. So in the meantime, I want to show you the other example for quick start with Helm. As I mentioned previously, there is this little issue with the Helm script because for one resource it doesn't use the URL but the file referenced from local directory. Sorry for that. Let's see the quick start for Helm again. So as you remember, we are installing the dependencies. And here we have this one object that should be actually propagated by URL. But if we were to call this script from this directory, it should already work. And I also just recreated the cluster here. So let's see. But so nothing is here. And now let's run the quick start Helm. And let's run a watch to see the installation. While we are having this installation in progress, we can also go through the values here used. So both for the Argo CD applications and for the Helm charts, we are using this value presented in here. And let's see what parameterization had to be done to integrate with this Kubeflow Helm chart. So for Argo workflows, we had to specify this specific tag and a specific version of Argo workflow because Kubeflow doesn't support the version 3.4 and higher. So we are currently bound to this one, but so far this wasn't blocking, so there is no critical issue on Kubeflow components using Argo. There are some sanity values. So for example, the emissary, well, this is required by Kubeflow to run the emissary. But then the persistent setting, well, not that much. This will be using the database to store the archived workflows, which you don't have to do. But on the other hand, if you are working in an enterprise environment, probably some data retention policy is to be in place. So keep that in mind. There is one workaround connected to some parameterization options for Kubeflow. So in some places, the MySQL secret is hard-coded, or at least hard to modify. So while we will try to work on parameterizing this specific thing, we might need some workaround until this issue is fixed. So we reference this MySQL secret for the password and the same MySQL secret for the username. Use default artifact repository. This is also important because otherwise Argo workflows will try to get the namespace configuration for the artifact repository, which should serve, which should be stored in some config map, but we can just use the default in here. Then this artifact repository is important because this is where the logs and the artifacts from Kubeflow pipeline steps will be solved. Then this access, this secret key, I'm not exactly sure if it was hard-coded or not, so I will try to look further into that. There are still some things that needs more investigation and development, and this is work in progress as mentioned at the beginning, but it already proves to be a pretty good installation method. How is the deployment going on? It's going on. So, okay, we have went through the Argo workflows. Let's see the Cert Manager. Here, only the install CRDs configuration was needed. There is a chance it might be modified to omit this specific thing. It was just the easiest way I found it to make it work. For the DEX, most of those values you should be already familiar with because we have to specify the OIDC client ID, the secret, the issuer, the storage, the web, logger. All of those things are just how you would see them in the Kubeflow manifests repository. I don't think that there is any change. Even the Kubeflow OIDC out service and the client secret are exactly the same. And the static password is also exactly the same. Oh, this was changed. Redirect URIs, and it was a different URI for OIDC out service. But technically, the latest version on branch master of Kubeflow manifest already is using OAuth2 proxy, so it would also should look the same. What else? Istiod. So this is the configuration to enable external authorization provider. So this configuration says that if we were to use OAuth2 proxy provider through authorization policy, Istio will first send the request to OAuth to proxy to verify if the traffic is authorized. And it will verify the cookies and the authorization headers. And OAuth to proxy then should be configured to trust both DEX and the OIDC issuer for end-to-end tokens. This specific configuration also changes the usage of envoy filter to specifically this config. So it is basically a replacement. What else? Istio-ingressgateway. We only had to change the service type because by default it was the load balancer as far as I remember, and we changed that to cluster IP. Kubeflow EKS. So this is not used in any of the current examples, but it shows what minimum set of changes is required to enable and integrate using Kubeflow on EKS with this Kubeflow. So first of all, you have to specify the dedicated OIDC issuer for your EKS cluster. You have to set the self-signed auto Jwks discovery. So this is the CronJob to false, and in cluster false. So in cluster option creates cluster role binding for a very specific purpose. Let's see if the other installation not this one. Do we have Kubeflow already? Yes, we do. Oh, this is minio. Right, we have Kubeflow here. So this specific manifest object technically is added when this option, Istio integration machine-to-machine in cluster, is set to true, which is the default for vCluster and Kind installations. The requirement to create this specific object is related to the OIDC discovery. There is this specific endpoint. Right, so the certificates are self-signed. So if we trust the certificate, this is the well-known OpenID configuration. And we are able to get to this part and to get an output because we have this cluster role binding. If we were not to have it, this would fail. And we can verify that by simply deleting this object. And as you now see, the output is forbidden. So that's why it's needed. And it was either the job or some of the services like OAuth to proxy or Istio needed to get there. I think it was OAuth to proxy because Istio we configured with the manually embedded Jwks. All right. But let's apply that back. And it should be working back. Yes, it is. Okay. And and this Helm quickstart script also has finished. Everything looks correct. Argo CD is not installed, and we should be able to call the API again. So this will get, this will got the experiment, but we didn't create any. And now we want to create. Here we go. And get again. There we are. So this was installation with the Helm script. It uses just the Helm charts and one manually deployed object just for the Kubeflow profile. And actually, let's see this object. It's just that, the standard profile CRD. So you can actually, no, I wanted to say you can use the script and deploy that manually, but you would get an error. So yeah, this wouldn't work. But Argo CD quickstart and Argo CD app of apps is working. Now, I wanted to recreate this setup on WSL just to show you that the access to Jupyter Web App is working. Oh, no hub. I mean the port forwarding. Oh, this is interesting. This happens because the cluster was redeployed and there is a cookie already present from previous deployment. So the easiest thing to do right now is to go to the data and clear the cookies. If I'll do it just like that and refresh, it redirects me to the login page, and there we go. So it is a new cluster, so the runs are not existing anymore, but let's create this new notebook just to show that it is working as well. All right, it should be working. And we are able to connect. Let's do some test. All right, so Kubeflow notebooks are working as well. And here I was showing the values for Kubeflow EKS and explaining the JWT. So let's move forward. What are the values for the metacontroller? Just changing the repository because I was occasionally hitting the Docker Hub pull rate limits. What's there for minio? Just to say that the sidecar injection is set to false. There is definitely some configuration for minio around Istio that would not have to provide this label to disable Istio sidecar injection, but it was the easiest thing to do right now. Also, because as I mentioned, the passwords are currently provided as a plain text, it's just in here in the same manner. So this is minio. For MySQL, we are doing technically just the same, and we are also specifying that we are creating additional database called Argo, and then this database is referenced in Argo workflows. This is only needed for the persistence, so the providing the archived workflows. What else? Let's show the OAuth proxy. So this is something that also needs to be modified if you want to change the machine-to-machine OIDC issuer. Now this is using the self-signed, so the Kubernetes service. And the format for OAuth proxy is the issuer equals to audition. If you have multiple auditions, just one of those should be enough. Here we are saying that this is the OIDC issuer. Oh, and there is a difference between how we handle DEX and Kubernetes issuer, because for DEX, we are basically saying this is your main issuer, this is the thing that you trust and you redirect to for logging in. But this is a little different configuration. This we say, and this also has to come with this. So we say skip JVT or JOTS bearer tokens, and we specify what kind of tokens can be skipped. So the first kind of token would be the one defined with OIDC issuer. But here we can also define a list of additional issuers. So what will happen? I move to proxy once authorization header with this token issued by this issuer, when this will be present, it will just verify against the Jwks from this issuer. It will verify the keys, the algorithm, and so on. And its final decision would be to either block if something is not wrong or skip. Now, this skipping is important because skipping by itself doesn't do anything. Now, we need to configure Istio to actually know what to do with those tokens. And this is a very nice configuration because no matter if you are going from the machine-to-machine path or through Rex, the output of OAuth to proxy are the authorization headers. So because of that, inside the because we have this information now inside the traffic, we can start integrating that with Istio. So in Istio system, we have these request authentications, and one of those is for DEX, which is just saying if you find JWT with this specific issuer in the incoming network traffic, trust it and provide this specific claim to this specific header. So just the email. This is what we care for. And then we have this other, which was already shown, but let's show it again. This also says that if you have this specific issuer, verify against these Jwks. And we had to specify this manually, again, because of the self-signed issuer. If you are running on EKS or some other setup that doesn't have self-signed issuers, this is not needed because Istio will call the well-known OIDC configuration by itself, as it does here. Right, and here we are saying that we want to take the subclaim and put into this specific header. And then, because Kubeflow uses subject access review and token reviews, both of those formats from the service account soup and email will be handled correctly. Right, so at this point, I only want to add some additional notes. So what's missing currently in the setup? So parameterization of secrets for database and object store, as mentioned, some work is needed on the Helm chart itself because currently only plain text values are supported for development. That's just fine, but obviously not for production. Also, we have to verify what are the parameterization options of Kubeflow itself in that matter, because if I'm not mistaken, the MySQL secret is kind of hard-coded. It might be the same for ML pipeline artifact secret. So maybe this will be important. We will have to see, but definitely some work on the Helm chart in that matter will be done. Admission webhook for pod defaults. This is not added yet. PVC viewer, volumes web app, same story. For TensorBoard and Katib, we have to yet align because Katib, for example, it provides a Helm chart of its own. TensorBoard, I'm not sure yet, but there's probably something similar. And then to mention on who's working on the Helm chart at the moment. So the work is in progress by the team of dedicated and experienced engineers in my company, which includes me as well. Current plan is to bring this Helm chart to production state within a month, because we have reached a decision that the project I'm working on should upgrade to Kubeflow 1.8 using this Helm chart. This Helm chart is a base artifact and by itself shouldn't be considered a distribution. You can treat the quickstart scripts as a very basic examples of distributions, but I'd actually rather call them POCs or developed distributions. There is the idea of providing additional Helm chart that would focus only on deploying the dependencies. So instead of running the scripts that installs Helm releases one by one or argues the applications in the correct order, it would be just enough to execute Helm install Kubeflow vanilla or something similar. Then this could be called a distribution like Kubeflow Helm Chart vanilla or something like that. But if this is going to happen and how, this is yet to be aligned. So this is everything I wanted to share. It came as a longer video that I anticipated, but I hope it provides you with all the information that you might have questions about. So we touched on what was the idea behind this Helm chart, what are the assumptions, the scope, the coupling, the conventions, some of the quick starts, examples, went through the values for the Helm releases for each of the dependency, and showed that the Kubeflow notebooks, profiles, and pipelines are working. So that's pretty much it. Thank you so much and have a great day. Bye.